εξοπλισμός είναι μια χαρά.
So we can start.
Ναι, δοκιμάσαμε τον.
Hello everyone. I'm glad to see you all today at our first English-speaking BeerPHP meetup. Thank you for taking the time to join our community this evening. And a special thanks goes to our host XM. We've come here for interesting discussions and lots of new ideas. For those of you who are joining us for the first time, let me remind you that BeerPHP is an open community for PHP developers who gather in an informal setting to discuss technologies, share experiences, and of course have a good time discussing our favorite programming language and enjoying some beer. Today's agenda includes two speeches. The first one is mass payment processing, a journey from manual to automation by Andreas, who is senior team leader at XM. And the second is what's under the hood of Symfony Messenger by Alexander, who is developer at MyFlower. And of course, live discussions and networking during the break between and after the speeches. Feel free to ask questions, suggest topics for discussion, and share your experiences. It will be a great opportunity not only to learn something new, but also to make new contacts and find solutions to some of the challenges you are currently facing at work. So let's get started. Wishing everyone to a great meetup, and thank you for being here with us. And our first speaker is Andreas.
Hello everyone. Welcome to XM. Hello, my name is Andreas Christodoulou. I am a tech lead of the funding stream here in XM, and I have joined XM in 2014. So I've been here a couple of years, and I've seen the company growing from a very small company to the monster that it is today. So let's get on. I would like first to introduce you XM as our sponsor today. XM is a leading international fintech company established in 2009. It has over 1,400 employees around the world. Our headquarters are here in Cyprus, in Limassol, but we operate also in other countries of the world, as you can see here. We support more than 30 languages, and we have over 10 million clients worldwide. Our core values are big, fair, and human. We live by that as much as possible. And with was great news today that we got announced that we got ranked third place in the Fortune 100 Best Companies to Work in Europe 2024 for the large companies categories. So thank you, XM, for this opportunity to host the event today. Right, I guess you are all here for the topic, so let's move on. I would like to see some hands raised. Who has worked with queues? RabbitMQ, Kafka, SQS, SNS? All right, half and half. So it will be, I guess, an opportunity to learn how we did our things through the queuing systems, but also for the ones that haven't used it before. I hope it will be a new experience for you and help you see things from a different perspective as well. So let's get started. Everything started back in 2016, where we got our first request as a payments team to automate the bulk processing. So how did we handle it? Back then we took the most obvious approach, as you can see. We created a cron job make an API call to the payment provider, fetch the batch of transactions, process them, and then every 30 minutes we are doing the same thing. What did we gain from this? Our transactions processing time was increased to 900%, processing in general, the transactions. Our back office could handle new tasks. We have their hands offload. And payment processing became 24/7 for this kind of mass operations. But of course, with every big implementation, with every new one, there are some challenges that we didn't predict, unfortunately. So we faced some issues. We had some duplicate payments. So having a cron job doing all the processing for you, if another cron job starts at the same time, we had the risk of having duplicate payments, and this happened in the past, unfortunately. But we always learn from our lessons, from our the issues. Also, to resolve this problem, we fixed the number of transactions per batch, let's say 100 per batch. So that fixed the duplicate problem. But that leads to another issue, to cause delayed payments. Because S batch, let's say, was handling only 100 transactions at a time, when the transactions start getting increasing and become more than 100, they have to wait for the next cycle of 30 minutes or even worse to be executed, and that unfortunately caused delays to even more delays to the payments and customers' frustration. Also, we had some manual interventions when something failed, more specifically when the batch was running. If we were using doctrine library, specifically ORM, and when an exception was thrown, like a timeout or unique constraint, unfortunately that was destroying the doctrine state and we could not renew it. As a result, we have to manually intervene and fix the issue. Lastly, as our clientele got bigger and bigger, more transactions as well, it means that that solution was not efficient and could not keep up anymore. So, what could we do about it? How did we fix this problem? Refactoring time. I guess our developers' time to refactor is the best time, I guess. So let's see the next improved version. We split the feature in two parts. By the way, we're going to see some code later. I'm just giving you the gist now, so stay with me. So we had break the feature into two parts. One, to fetch the transactions from the payment provider, add them in a queue, and part B, to process transactions by having consumers that will be reading from the queues. We also created additional tables to store those transactions fetched from the payment providers in the database. So in case the queuing system was down for any reason or for maintenance, we would at least know that something failed so we can reprocess it later on. And for that, we had a custom mechanism in the UI in order to retry those failed transactions. In addition to this, we added unique index constraints on that table to prevent having any race conditions that could cause duplicate entries. And last but not least, we added the transaction status check to avoid also processing the transactions more than once. As I said, we use queues. More specifically, we use RabbitMQ. For the ones that they don't know, RabbitMQ is a queuing system that you can send your message, so it supports PubSub, publisher subscriber. It offers a very good UI which can help you see your queues, number of messages in each queue. You can add messages through the UI or remove messages. And something that we use, specifically a feature we use from RabbitMQ, was the dead letter exchange, which is a feature of RabbitMQ. In the case a payment failed to be processed, it will be sent back to the dead letter exchange and be retried after a pre-configured time. In general, dead letters are messages that are republished to an exchange when one of the following issues can happen. like the message is negatively acknowledged or expires due to a per message TTL, or the message is dropped because its queue exceeded the length limit. But wait, what will happen if we reach the max number of retries? How did we handle that part? For that one, again, we created a custom internal tool that through a UI, it allows our back office to be able to retry those failed operations. Okay, next to that, in order to make it even more efficient, because things can go wrong, we added some monitoring in place using Zabbix. So for the ones that they don't know, Zabbix is a monitoring tool that helps us to monitor our queues. So when our, let's say the message, the queues reach to a certain threshold, to be alerted, because of course, as I said here, things can go wrong. For example, we can have an increase in the number of deposits, so the consumers cannot catch up, thus we need to increase them. Or consumers might die, or the supervisor could not start the new ones. And even worse, the servers could die as well. So having a monitoring in place is very good and suggested approach, that you can find things when happen and not be notified by the clients that something went wrong. Here is a complete design of our whole setup, with the cron jobs on the top and consumer at the bottom, both consuming and interacting with the database. The RabbitMQ, again, with having the queues with the messages, Zabbix for monitoring, and the payment providers. So let's see what did we gain from this version 2. We achieved a new record of 500%. As transactions were in the queue, each transaction could only be picked up from one consumer at a time and be processed. We resolved delays. We started with 5 consumers running in parallel, and once a consumer is completing the processing of a transaction, it could pick up the next one. In case the number of consumers were not sufficient, we can do vertical scaling by increasing the number of consumers in our configuration. We set also a consumer's lifetime to max 5 minutes in order to avoid keeping database connections for too long and getting timeouts, but also this helps us when deploying new codes, and time pass, the running consumer with the old code will stop and supervisor D will start another consumer with a new code. Also, we improved the onboarding process of payment providers by introducing design patterns and solid principles that we'll see in our next slides. So before we jump into the code, let's meet our stack. Of course, is PHP. We are all here because I guess the majority is PHP. We have Symfony framework. For the ones that they don't know, Symfony is a PHP framework. And we are using also Doctrine library, which help us to connect to the database and perform various transactions, more specifically to MariaDB. As mentioned, RabbitMQ for the queues, Zabbix for monitoring, and Supervisor D, which is a system that monitors if your consumers are up and running, and it's read from your configuration to have a predefined number of consumers up and running. So if it detects that there is something wrong, it will try to recover the number of consumers. Okay, next one, let's see some code. We have created an interface where it has been implemented by all the payment providers, which can accept a request, and each PSP will need to provide back a result in a DTO form. So that helps us to be consistent and also to add more PSPs in the future that will follow the same principles. Another good feature that we have used is the Symfony Service Locator. As I showed in the previous slide, we have implemented the interface where each payment provider has to implement, and we declare each of that implementation as a service inside Symfony. That also allowed us to use the service locator of Symfony to inject. So there is a queue here of payment providers, which is used by later on by our consumers in order to understand when you will be reading the messages from the queue to which payment provider to assign the handling of the message. Okay, next one we have the runner interface. Again, this is a service that implements inside each PSP separately. So we use the middleware approach here, which is a type of chain of responsibility design pattern. It allows us to easily add or remove handlers. Handlers are small tasks like cache the results, logging, and other things, instead of having a big class handling all the operations. And we can change the order of the task very easily, as you can see. And just for the record, we only retry transactions that they have failed up to the deposit handler, as you can see in this screenshot, which means that they fail to be added in the client's trading account. Because the end goal here for us in the Forex industry is to fund the client's trading account. So as you can see here, the deposit handler, it's, as we are going to see later on, is one of the things that it's doing is funding the trading servers. And lastly, regards to the last handler, if that one fails, we are taking manual action. There is nothing automation here, as we then consider it as very essential to the business. Okay, here we can see another handler implementation. Pay attention to line 25. We have the ability to either return a transaction DTO and complete the whole execution, or we can call the next handler in the stack. As an example, we wanted to wrap up all the handlers under an execution handler to catch all the exceptions, and we have a uniform approach of handling them. Right, now let's take a deep dive inside the code and see some more insights as well. Can you see in the back? Is it good? Thank you. Right, starting from the queue processor bus, this is a service used inside the consumers that will read from the queue, and using the service locator, it will pass the provider's name and will try to choose the one that can handle this message. And here it's calling, as I showed earlier, the interface, the method that is implemented by all the payment providers. Next one, we have the exception handler. As you can see, the exception handler wraps up all the calls to the next handlers inside the try catch, so you can handle all the exceptions in a single place. Next one, we have the logger handler, which, as you can see here, when something starts, we are also handling. We are logging we are logging that the process started, and then we are passing to the next handler. Next one, we have the caching handler. We created a handler for performance in order not to spam the database all the time. So when something comes for the first time, is not in the cached, we are caching it. So here we're trying to see if it's inside the cache, if it was hit. So here we're using also the cache pool service from Symfony directly, and behind the scenes we are using Redis for caching. If it's cached, it will exit the process. If it's not, it will try to call the next handlers. If everything goes well, it will cache the result. If not, the exception handler will catch it and make what is needed. We have also duplicates handler. Here we're using the doctrine behind the scenes to speak with MarianeDB and call the database to see if that transaction is already in our database. And last one, in the, let's say, the most important handler, which is handling the payment. When reached at this point, it means it passes all the checks, and we are raising an event here that deposit order has been created, and using the Symfony events, we are dispatching it. When we have listeners behind the scene, you have a number of listeners that they are doing several things like funding clients' trading account, sending email to the clients, internal emails, and a lot of other things as well. Okay, lessons learned. Not recommending using Doctrine ORM for bulk operations, because if an exception is thrown, like we lost connection lost or unique constraint exception, the doctrine state becomes invalid and they use doctrine debug instead. Asynchronous operations is your friend. It allows a company to grow and handle bigger loads without impacting the stability of the systems or client experience. Use supervisor D. Use supervisor D. It can run in Unix-like systems and it can monitor if your consumers are up and running. In case it detects less consumers running, based on configuration, it will start automatically new ones. Supervisor D is your guardian and will never let you down with any consumers. Next steps for us. We're in the process of migrating our code to Symfony Messenger, which is also our next topic, and remove the dependency we have now to the RabbitMQ package. That will give us the ability to use an abstraction layer and move away from Redis or from a queuing system we have now, RabbitMQ, and choose other ones like, as I mentioned in the next one, we'd like to also explore AWS queuing services, as we are doing a big shift there to AWS. A lot of our systems already moved there, and we'd like to explore and see what kind of queuing solutions are out there, managed or unmanaged solutions, that will also help us to optimize the way our consumers are now running, like even stopping the consumers that when there is no traffic completely, unlike now that we always have consumers up and running in the current setup. Thank you very much. So this is the end of the presentation. Don't know, I would like to take some questions if you have. Yes?
I see you want to integrate with Kafka and RabbitMQ.
So let me give you the microphone.
RabbitMQ is not enough for you for now. Why you want to migrate to Kafka?
RabbitMQ is a unmanaged service, so the whole setup was, let's say, it's also adding additional cost. Kafka, this is only set up specifically for us. Kafka is something that we have set up for the whole company and it's being used there. So it's also in terms of cost, but maybe efficiencies, in terms of maintainability and maintenance as well, performance maybe. But we are also open for exploring other solutions like SQS or SNS, some managed solutions. So again, it all comes to cost, performance, maintainability, and so on.
Thank you.
You're welcome. Anyone else?
Is it run on EKS or no? I mean, if it's EKS, why do you use supervisor D?
At the moment, the application is not running in EKS. We are shifting in that direction. We are actually pretty close to move to AWS. We wanted to make as less changes as possible to the application and to the infrastructure in general. Migrate there, and then we will start checking out, as I said, what kind of queuing systems are out there. So we try to reduce the scope because we're talking about, this is a huge application. We're talking about the payment gateway. It has millions of requests, so it's a very critical system. So we try to reduce the scope and the risk in order to go faster as well and give us the option to explore more things.
Yeah, thank you. One more. When your set of handlers, like pipe handlers and whatever was that, if it gets interrupted, is it resumable or how does it work?
Yeah, as I said, when we reach up to the last handler and we get exceptions,
Interrupted in the middle.
you are talking about the handlers, let's say login, caching, exception stuff, right? Those handlers?
No. There was another picture with more handlers. Third-party handler, for example. Yes.
Third-party handlers. Yeah, if that happens, if that fails, yeah, it's going to be retried. As I said, we are using the dead letter exchange, so we know that when it will reach to certain handlers, that we are okay if they fail to be retried again.
Okay, so every handler works this chain of handlers, is it synchronous process or everyone is like dispatched and asynchronously?
It's sequential. It's one after the other. So one handler will do its job and then move to the next one, to the next one. But regards to the processing of the messages from the queue is done in parallel.
Okay, got it.
Thank you.
As I saw, you still use cron in finals gem, but why you use cron tab? You can put immediately in consumer all your tasks. Why you use cron?
The cron job, actually we use it for the first part that we are fetching the transactions. So that's, let's say, a scheduled job that is happening every 10 minutes just to fetch the transactions and store them in the queue. So the consumers is the second part, we just reading from the queue.
Okay, but you get still using cron to fetch transactions. You can subscribe. You can make event to put transaction immediately in consumer without any cron jobs.
You are saying that we could fetch the transaction directly and process it? It's a heavy operation because we are talking about a huge number of transactions. So we are fetching the batch from the providers, storing to the database all the transactions, and then we just pick one by one from the queue to process it.
Thank you.
You're welcome. Any other questions? Going once, going twice. I will ask him first. Yeah.
You said many transactions, but how many? It's how many thousand millions transactions?
I cannot disclose, it's confidential.
It's just a quick question. Christodoulou and deployment.
Yeah, so as I mentioned, in each deployment, we are actually having graceful shutdown. So, yeah, so we are not actually killing the consumers at that time. We leave it to complete. We'll die when we'll finish processing the consumer. We'll die, and then supervisor D will start another consumer that will be reading from the new source code. But we also, if we want to do it immediately, we can also have the ability through supervisor D to go and stop the consumers and force it to start and pick up the new code. Let's say we have an error in production that's critical and we cannot afford waiting 5 minutes to kill. We can do it through supervisor D.
So you for example, you decided to deploy new version of processing of transaction. So you still have old version messages, new version messages, and it will be dangerous, I think, because you have different versions. How you handle it?
Yeah, so when we're deploying, mainly we are if we have a change in the message, we are using versioning.
You have version.
Yeah, we have versioning on the messages. So in case we want to change the schema of the message, do some, add something, remove something, of course, we are going to create a new version. That way, we will create also a new queue on the RabbitMQ. And then when we deploy, and we are going to leave to complete first whatever is in the old queues, and then we are going to deploy in order to pick up and start processing the new ones.
So after deploy, then you handle all messages with old version. You need to kill old queue with that handles old version messages, and new version still working.
Okay, so what we actually do, we are going to start publishing to a new queue. So we deploy that one. At the same time, we keep the consumers to process whatever is inside to the old queues. When they finish their job, then we're going to deploy the consumers to start reading from changing the configuration actually to read the new version of the queue.
How often it happens?
What exactly? What do you mean? What happens?
How often you change messages?
The version.
Yes.
To be honest, Mari, rarely, never. I think probably we did it once. I don't know. Maybe we are. Yeah. So I will say maybe I remember at least one or maybe twice. Yeah. So yeah.
Because changing version is always pain. So
I don't think it's a pain so much. It's mainly a configuration. So we have it on configuration level. So for us is changing a flag. So it's just a configuration. You deploy it so we have it also enabled when we start publishing to a new queue, I think, to create the queue if it doesn't exist. So the new version will automatically be created, the Q1 on the RabbitMQ. We leave it there and we start publishing any new messages. And the old ones will be read from the consumers and then we'll republish. But in general, to be honest, I remember once or maybe twice that we reached the point to go and change these. Yeah.
First of all, thank you for your speech. It's great. So the question is about the cron job. I think maybe it was not enough clear. As I understand, you need cron job for get transactions for the third parties.
Mm-hmm.
Yes, not from your own services.
Correct.
Yeah. That's why it's needed cron job.
Yeah.
Yeah. Okay. Thank you.
Yeah. So maybe I don't know. Maybe that was not very clear. But yes, if the transactions, the deposit, let's say, was added from an internal queue of us, we could raise an event at that time and add it directly, no cron job. But because we have to fetch those transactions as a bulk operation, we have to go and ask the PSP to give us a couple of hundreds, a couple of thousands of transactions. So we split this into these parts. Right, so if there are no questions, thank you very much.
Thank you, Andreas. So now we will have about 15 minutes break and we will start second speech.